Alright, so that first video ended off with these rules for combining random variables. Didn't have time to squeeze in this example and I didn't want to rush it. So in a certain game you got a 5% chance of winning the grand prize of $50 and a 30% chance of winning the smaller prize of $15. And if it's not one of those two, then you're going to lose. So I would say let's set up a probability distribution. If X is winnings, and you got X and P of X, the probability that X happens, could win 50. There's a 0.05 chance of that. Could win 15. There's a 0.3 or 0.30 chance of that. And you could lose $10. There's a 65 or 0.65% or 0.65 chance of that. Okay, so let's figure out the mean or expected value. We use both of those notations either. They're interchangeable. 50 times 0.05 plus 15 times 0.3 plus negative 10 times 0.65. So we expect on average to lose 50 cents per play. Ugh, not good. What about the standard deviation? It's the square root of the difference of the first one and our, let's go 0.5 for our expected value, just so we don't have to write less pure characters. We're going to square that and we're going to multiply it by its probability. And you're going, the standard deviation is different than it was earlier in the lesson. Well, this is for a random variable, right? So this is our standard deviation equation that we learned from last class, where we take each value, subtract the mean or expected value, whichever one we want to call it, square that, and multiply it by its corresponding probability. So we're going to do that for all these guys. I'm going 4 decimal places, even though the units are dollars for the standard deviation. All right, what's the expected profit and standard deviation if the game is played twice? If the game is played twice, that's mu of 2x, which we said on the previous page is 2 times mu sub x. Which is 2 times 50 cents. Or $1. You know what, I was thinking initially that we were losing 50 cents per play. That's not terrible. If we play twice, we've won $1, or we expect to have won $1. What's the expected profit and standard deviation if the prizes and losses are all doubled? Okay. For this guy, we're going to have a new probability distribution. And X is still winnings or profit. So this becomes $100. chance is the same. This becomes 30 bucks. Chance is the same. Now we're losing 20 bucks. Chance is the same as previously. Okay, but we don't have to recalculate the mean and standard deviation. If we double the profit, we know that we're gonna, what in the heck? We know that we're gonna double the mean, the original mean. So it's $1. In my notes, it looked like 100 bucks. Okay. What about the standard deviation? Well, it's going to be 2 times the original standard deviation. Let's do this just to be a little more clear. And this was 16.0390. So this is 32.0780. No, we didn't do the expected value. I mean, sorry, the standard deviation up here. Let's do that too. My apologies. Sigma of x plus x. Man, this thing is, I don't know if my screen's dirty, but it is misbehaving today. Which is kind of surprising. It turns out it doesn't matter in this particular example if you play the game twice or if you play it once and double the winnings and losings. You're going to end up with the same mean and standard deviation. Okay, what's the expected profit and standard deviation if the game is played 200 times? That's 200 times the mean, which is 200 times 50 cents, which is 100 bucks. What about the standard deviation? 200 times the standard deviation. My goodness. Sorry, guys. Which is a bundle now. We could be off by quite a bit. We could have a huge spread here. 3,207.8. Okay, that's this lesson. If you have questions over any of these guys, come and see me during tutoring.